Yeah, it's Miss Johnson. What up? I'm recording the lesson before class, which is kind of exciting. All right, y'all. In class today, we talked about the graphical representation of the integral being area, and then interpreting the definite integral as like finding the area between 2 points in the graph, x values in the graph. So let's practice that, right? I'm going to do two of these types of questions on this video, and then you're going to do 2 for homework. It's going to be great. Let's go for it. First, I'm going to put equals. No. Do this instead. Okay, so given this function, let's write the indefinite integral for this function. So the indefinite integral is just when we put the integral sign, we put the function, and then we put dx. I had written it already. I'll have to change that on your homework. Bada bing, right? The indefinite integral, there's no boundaries, and the answer is an equation, right? And the answer is, part 2, find the antiderivative, right? So this is where we actually say this is equal to, and now we use the power rule. We're trying to find the function that has this as its derivative. Okay, well, we know this is going to be a 3. First off, we can just think about this. We can say something with the exponent 3 will have the derivative with the exponent 2, or we can look at our notes. We're not done this shit quite yet. Or we can look at our notes and we can say that the integral power rule says that, right, that we kick it up by 1. And then we come over here and we say, well, in order for this to be 2 eventually, it would need to have been 2/3 here because these two things multiplied needs to be 2. Or again, we cannot think about it every time. We can have done our thinking when we wrote the notes, and then we can just say, oh, well, a was 2, n plus 1 was 3. Here we are. Same thing here. This is going to be minus x. We can think about that really hard, or we can look at our notes where we have, this example or something. And then antiderivative always involves the plus c. So we'll put that. All right. Sketch and shade the graph, shade the area from 1 to 3. It's totally fine. Let me move my face. Put myself here. I'll draw a graph. Make those lines smaller. Draw a graph. I will say, when I'm sketching the graph, this is the graph of the original function, not of the antiderivative. We'll use the antiderivative later. So original function. Nice. So this is y equals 2x squared minus 1. Right, minus 1 means it's going to be down 1. 2x means by 1, it's going to be a 1. By 2, 2 squared is 4. 8 minus 1 is 7. So we'll just call this 7. Have fun with it. Right. And then we will graph this. Let me move this down a little bit, just so it actually looks like what we want it to be. Your graph doesn't have to be perfect here. It just has to be, reasonable-ish. And then for 3, it's like all the way up here. And then shading the area from 1 to 3, we draw a line at x equals 1 up to the function. We draw a line at x equals 3 up to the function. And then we shade in that region. Bingo bongo. That's number 3 done. Move myself back. And now calculate the area of the shaded region. This is just the same thing as the definite integral. Integral with 1 and 3 as the boundaries, right? So I'm going to write this as the integral from 1 to 3 of 2x squared minus 1 dx we already know what the antiderivative is. We put this bar from 1 to 3. And then we plug in 3. Minus plugging in 1. And we're always going to put parentheses around plugging in 3 minus plugging in 1. And now you can bring out your calculator. That's going to be 2 times 9 minus 3 minus 2/3 plus 1, because I'm distributing the negative. 2 times 9. I'm just going to do it from here. 2 times 9 plus minus 3 minus 2/3 plus 1. Looks like we get 15.3 repeating. And that's our answer. This is the area of this shape, right? Instead of doing length times width, instead of doing pi r squared, instead of having some geometric formula for this area, we have to use calculus because one of the sides is curved, and so far geometry hasn't really given us a great way to find this area. All right. Let's try it again. The process is the same. So if you understand the process and you're feeling good, you can just pause here and do the homework, right? I just want to give an example with trig because maybe it's been a while since we thought about trig. All right, again, given the function this, right, the indefinite integral for this function, the indefinite integral is the integral of cosine minus 1 dx, right? Bada bing. Finding the antiderivative, so actually doing this, we say what has the derivative of cosine? Sine, right? And then what has the derivative of -1? It's -1x. And then we'll put the plus c because this was an indefinite integral. Fantastic. This is our area function. It's called our area function. It's also called our antiderivative. It's also called our, indefinite integral. There's a lot of names, but the reason it's called the area function is we're going to use it when we calculate the area. Okay. Let's sketch our graph fast, though. And again, sketch the graph of original function. So let's get ourselves graph. We're actually going to move this one up because we've got -1 here, -2 here. We'll put pi here. We'll put 2 pi here. And then when we graph y equals cosine x minus 1, I am going to put my middle line at the -1. I'm going to sketch some key points of cosine, and then I'm going to connect my dots. Then I'm going to say it's from 0 to pi. So I drew lines from the x points to the function. Because 0 is on the function, I'm just going to leave it there. And then, boom, that's the area we're looking after. Calculate the graph. That's taking the definite integral from 0 to pi of cosine x minus 1. We already know the antiderivative. We leave off the plus c here. We don't really care about it because it would cancel out once we plug in pi and 0 and subtract them. And now we're going to plug in pi and 0 and subtract them, making sure to put giant parentheses around both of those things, right? Especially if you're using a calculator. If you're using the calculator, remember, use radian mode. But you haven't heard that sentence in a while. Use radian mode. But to be honest, sine of pi is 0. minus pi minus sine of 0 is also 0. So it's just going to be negative pi. We can expect this to be negative because it's all under the x-axis. So this feels good. Usually when people say what's a negative area, we say, okay, fine. The area is actually pi, right? Because area is also this like physical thing that having a negative area doesn't make sense. But when we do the definite integral, it makes sense to get a negative answer because it's under the x-axis. But under the x-axis. Y'all, that's that for that. If you have any questions, today's office hours are pretty structured, so email me, but you can always ask in class as well. All right, see you later. Stop sharing.